this video, I'll show you how to repair the Tronsmart Force speaker if it has stopped charging and won't turn on. We have this kind of high quality and durable speaker. It's waterproof and reliable in design. It has an input voltage of approximately 5 volts, a power of 3 amps, which is the maximum current consumption. Made in China, model Force, and overall it has stopped charging. I'll show you the symptoms of this malfunction. When I connect the Type-C charger to the device, the small red LED light located near the power button starts to flash intermittently, indicating some activity. However, despite this flashing, the device stubbornly refuses to charge or power on, leaving me puzzled and concerned about the underlying issue. We need to take it apart and find out what the problem is. I suspect the problem is with the battery. First, we unscrew the mounting bolts from the frame on the back side. Let's remove the frame. There's a mesh underneath it. We also need to remove it. I pried it open with a flat screwdriver. There are speakers here. We need to get to the central part of the control board. Let's remove the same mesh from the opposite side. Here, it's glued down with some kind of adhesive to prevent it from rattling. So, there are bolts that we need to unscrew very carefully and meticulously to get to the central part. After that, we very gently and cautiously remove the top protective rubber layer. To get to the case, we slowly and with precision peel off the decorative part of this fastener using an awl and double-sided tape, and we unscrew the fastener from its place using a Phillips screwdriver. Let's carefully set the item aside for now. At this point, we can fully remove the protective rubber cover that is currently in place. This step is crucial to ensure that we can proceed without any obstructions. By doing so, we make sure that the underlying components are accessible and ready for the next phase of our process. It's important to handle the cover with care to avoid any potential damage. This is the protective rubber cover. Let's put it aside. Now let's unscrew the top lid to access the control board and the battery. Then we unscrew the 4 bolts that hold the control board, the corners. Now, using a ratchet screwdriver, let's take apart the entire speaker casing. There are some screws inside that need to be unscrewed. And after that, we open up the speaker casing. After that, we'll use a tester to check the voltage on the power supply battery. Here on the board, there are two terminals where the battery is soldered. Plus minus, the voltage is 0, which means the battery is deeply discharged. Now I'll try to desolder it from the board and give it a little jump charge. Maybe it will work. If not, we'll have to replace it. For desoldering the contacts, the plus and minus are labeled on the board, so you won't mix them up later. We're carefully disconnecting the battery safely from the control board, and we'll try to give it a jump charge using and securely. Of the charger. I carefully connected the charger to the battery using alligator clips, ensuring a secure connection. Now, let's proceed to turn on the charger and patiently wait for a little while for the current to flow smoothly into the battery. Once the voltage stabilizes, there is a possibility that it might start up successfully. However, if it does not start, then unfortunately, you will have to consider purchasing a brand new battery. While the charger is on, the voltage is 483 volts. When you disconnect the charger, the voltage should be the same, or just a little lower. Let's take a brief moment to carefully and thoroughly check this out. Let's disconnect the charger. And now the voltage has dropped to 0. This means that the batteries are completely out of order and cannot be restored. We'll be replacing them. To replace these batteries, I bought new 18650 batteries from VAPS with a capacity of 3500 milliamp hours. They're high quality, not cheap, and their capacity is real. We'll be putting them into the new battery. Let's disassemble the old battery and check what's inside. There's a self-adhesive sealing part here. This is in order to prevent the battery inside from rattling and causing any issues. I will carefully remove the sticker, ensuring it remains intact, and then stick it onto the new battery pack. This process requires precision to ensure the sticker is properly aligned and securely attached, which is essential for the battery pack's correct identification and functionality. If it tears, we will, for example, have to purchase a new self-adhesive strip, such as the one we used before. It's stuck on pretty well, almost doesn't come off. We need to carefully and meticulously remove the controller from this old, outdated battery, which is securely located inside the casing. Let's not struggle unnecessarily with it, as it can be quite challenging. Instead, let's take a more straightforward approach and cut it in half to make the process easier and more efficient. Let's see how it's built, what's inside it. Let's take off the casing. Inside there are two batteries like this. I don't know what quality they are because they're not labeled. Disassembling the battery showed that there was corrosion on one of the contacts. There are signs of oxidation. It might potentially be leaking electrolyte. So we need these clamps. Replace it so there won't be any problems later. I'm currently in the process of carefully and meticulously removing the controller from this battery. This involves gently and cautiously peeling off these protective strips so that I can later resolder them back into place with precision. And we'll do the same with the new batteries. Let's install it there. There's a T-shaped jumper at the bottom of the controller. I tried to remove it carefully. You can get the solderability together. If not, I'll make the same one out of copper foil. First, I'm going to glue these two batteries together, in reverse order using super glue in the center. Let's take a moment to allow the adhesive to fully set and dry. This is an important step to ensure everything holds together properly. Once the glue has dried completely, we will proceed to the next step. In this step, we will carefully place a piece of insulation material right in the center. The purpose of this insulation is to ensure that the controller does not come into direct contact with the batteries. This is crucial to prevent any potential electrical issues or short circuits. By doing this, we ensure the safety and efficiency of the entire setup, and we'll solder the controller here. Before soldering the controller to the batteries, it's important to check their voltage. It should be the same, otherwise they'll need to be balanced. The voltage on my batteries is exactly 3.75 volts. First, we'll tin the contacts of the controller. For this, I'll use a soldering brush. To ensure everything is working correctly, we must verify the balance and voltage of the batteries. This step is crucial for the proper functioning of the device. Additionally, when tinning the contacts, make sure to apply the solder evenly using the brush. I'll lightly process them. And I'll them with a bit of solder. The contacts are tinned, so we can solder them to the battery. In the next step, I will carefully apply a layer of solder to the contact points on the battery, ensuring a good connection for the subsequent assembly process. We're trying not to overheat. We heat with the most minimal and very briefest possible touches, very carefully and gently to the contacts. If it didn't work, we'll stop and apply it again only after it cools down. Here are the contacts on the batteries. Tinned. Let's wait a little for the battery to cool down, and then we'll solder them in this position with short touches. After that, we'll use alcohol and a brush to remove the soldering flux residue so that the contacts don't oxidize later and we don't run into problems like we did last time. We need to be a bit careful and attentive throughout the entire process so that nothing burns out. We meticulously and thoroughly clean and inspect the soldering points to ensure the highest possible quality and safety standards. It evaporates quickly, leaving absolutely no harmful acid residue whatsoever. After that, we'll insulate the ends of the battery, and then we'll put on the original casing that we removed last time.
We place the battery in the casing.
Here's the new battery, ready to go. Let's check the voltage on it, and then we can solder it into its place in the speaker. As you can see, the voltage right now is 7.3 volts, but after fully charging the battery, it will be higher. We very carefully and meticulously solder the battery into its designated place, ensuring that we observe and respect the correct polarity. After completing this step, we then proceed to the next phase, where we need to carefully and precisely assemble the casing. To effectively seal the joint and ensure no leaks, I'll use a high-quality black gasket sealant, which is known for its durability and reliability. We apply it around the perimeter. We'll just wait a little bit for the sealant to dry, and then we'll connect both halves of the speaker back in place. After that, we can tighten both parts with bolts. Fondue loves you and always will, and cherish every moment with you. And we screw the control board to the casing. We carefully cover the control board with the protective lid and securely screw it down with multiple screws, ensuring everything is tightly fastened. After that, we'll carefully and gently put the rubber cover in its place. Before we install the grills, let's check the buttons. Let's turn on speaker. The clone has turned on. The mode selection button, which is crucial for operation, is working perfectly fine. The volume control, an essential feature, works seamlessly too. So far there are no problems. In this step, we will carefully fasten the grill into its designated position. Use the correct screws and ensure each one is tightly secured. Align the grill properly and tighten all screws evenly to avoid wobbling or misalignment. This step is crucial for the grill's stability and functionality, so take your time to do it right. To ensure that there is no misalignment during the assembly process, we meticulously and carefully tighten the frame in a uniform manner all around the entire perimeter. This methodical approach helps in maintaining the structural integrity and alignment of the frame, preventing any potential issues that could arise from uneven tightening. By doing so, we guarantee that the frame remains perfectly aligned and secure, which is crucial for the overall stability and functionality of the structure. After carefully assembling the casing, we just need to gently and properly put this handle back in place, which is securely and safely used to carry the speaker. In this step, we have two standard screws that are specifically designed to be used with a Phillips head screwdriver. These screws are essential for securing components together. Once the screws are in place, I will carefully attach this decorative cover, ensuring it fits snugly and securely over the screws, enhancing the overall appearance and providing a finished look to the assembly. All set, the ring is in place. Now we just need to check how the speaker works. Let's turn it on. And we'll connect it to the phone in order to successfully, efficiently, and thoroughly test it.
The light is currently working fine, functioning as expected, operating smoothly, and performing optimally.
Let's simply connect the charger, using a Type-C cable. After plugging in the charger, the battery charging light came on. Let's wait for it to turn off and then easily and conveniently check the battery charge level using an app on an Android smartphone.